Let us evaluate the integral of x to the power 6 times square root of 1 minus x square as x changes from 0 to 1. So, we want to evaluate this definite integral and we want to do it using beta gamma function. We need a number of results like gamma p equal to p minus 1 times gamma p minus 1, that is a recurrence relation for gamma function, and we know that gamma 1 equal to 1 and gamma half equal to root pi. Further, we know that beta mn equal to gamma m times gamma n divided by gamma m plus n, and further beta mn equal to 2 times integral of sine to the power twice m minus 1 theta times cos to the power twice n minus 1 theta as theta changes from 0 to pi by 2. With this, we will be able to evaluate this integral. Let us write I equal to this integral. Let us do it. Now, see that somehow we want to apply this formula. So, obviously, we should choose x equal to sine theta. That makes our work easier. And observe that when x changes from 0 to 1, theta will change from 0 to pi by 2. When x equal to 0, we can take theta equal to 0. When x equal to 1, we can take theta equal to pi by 2. Sine 90 degrees 1. That is pretty simple. And so, I equal to integral 0 to pi by 2 x to the power 6. We have not written x equal to sine theta. Let us write it late. X equal to sine theta. And if we differentiate it, we get dx d theta equal to cos theta. So, I can say that dx equal to cos theta d theta. So, good. So, x to the power 6 is sine to the power 6 theta. 1 minus x square is 1 minus sine square theta, that is cos square theta, and root n square will get cancelled. So, we will be simply left out with cos theta. And then dx is cos theta, d theta we write as it is. Now, we can simplify it and write it as 0 to pi by 2 sine to the power 6 theta times cos square theta d theta. Somehow we want to use this identity sine to the power twice m minus 1. So, we want 6 to be equal to twice m minus 1, 6 to be equal to twice m minus 1. That is possible when twice m equal to 7 or m equal to 7 by 2. So, this can be written as sine to the power 2 times 7 by 2 minus 1 theta, and similarly cos square can be written as cos to the power 2 times 3 by 2 minus 1 theta d theta. Integral 0 to pi by 2, but we got beta mn equal to 2 times. So, just for simplicity, let us multiply numerator and denominator by 2. We multiply by 2 and of course, we multiply by half and 2 here, right. So, now we know the formula beta mn equal to this expression. So, let us use that formula. So, this is equal to half beta mn, m is 7 by 2 comma n is 3 by 2. Now, can we compute beta mn? Of course, we know how to compute. We know the formula, of course we know, but only for selected cases. So, let us apply that. Beta mn equal to gamma m times gamma n divided by gamma m plus n. So, we choose m equal to 7 by 2 and n equal to 3 by 2. So, that is equal to gamma 7 by 2 times gamma 3 by 2 divided by gamma 7 by 2 plus 3 by 2. 7 by 2 plus 3 by 2. Now, we will use the recurrence relation gamma 7 by 2. We choose p equal to 7 by 2. So, gamma 7 by 2 is 5 by 2 gamma 5 by 2. Gamma 7 by 2 is 5 by 2 times gamma 5 by 2. Again, we choose p equal to 5 by 2 to say gamma 5 by 2 is 3 by 2 gamma 3 by 2. So, gamma 5 by 2 is 3 by 2 gamma 3 by 2. Again, we choose p equal to 3 by 2 to say gamma 3 by 2 is 1 by 2 gamma 1 by 2. But we know the value of gamma 1 by 2, so we do not do it again. So, gamma 3 by 2 is 1 by 2 gamma 1 by 2. How about gamma 3 by 2? That is equal to 1 by 2 gamma 1 by 2. Okay. How about the denominator? 7 plus 3 is 10, 10 by 2 is 5, gamma 5. Gamma 5, we choose p equal to 5, gamma 5 is 4 gamma 4. So gamma 5 is 4 gamma 4. Again we choose p equal to 4 and say that gamma 4 is 3 gamma 3. Gamma 4 is 3 gamma 3, gamma 3 is 2 gamma 2, gamma 2 is 1 gamma 1. Alright. Okay, 5 times 3 is 15 divided by 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Gamma half is root pi, gamma half is root pi, then 4, 3, 2, 1, that's 4 factorial, but we can cancel 3 out. So this is equal to 5 pi by 16 times 4 is 64, 64 times 2 is 128, 128 times 2 is 256, and we are done.